Good up, Sam. Ebro, what's up, everybody?
Hello there.
Well, hello there. Do, do, do. Mm, mm, mm. Mm, 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 mm. Okay, that should be good. And we just got to start YouTube chat as well. Ooh. I'm definitely gonna check it out. Something like C++. Oh, the course. Nice. Yeah, it's live. Why you so late? I was, believe it or not, I was sending emails this morning. Ugh. Ugh. Disgusting. Finished chapter 1 yesterday, of course. Thoughts so far? Hello there. It's pretty good. Nice. All right. I was kind of thinking, chat, maybe we need an even goofier version of some of these. I think this one is pretty obvious what it's gonna do, so this one seems good. But I kind of feel like I do wonder if we should make some of these a little simpler. I've been trying to figure out how to make this video for too long, so let's just hang out and try and talk about it today and see what happens. Nice. Well, thank you, Lumen. We're just gonna hang out for a little bit. I'm gonna see if I can make something that you know, can accurately explain what we're doing. Languages, this is OCaml, but we're trying to make it look as close to C as possible. For the memes. So this is probably the best example. Return. What was the problem here? Doom. Huh, interesting. Because these two look like almost exactly the same. I'm doing great, Abu. What about you? What's up, Ferris? Purplish. Good to see everybody. So that's kind of what I'm. Maybe go one size smaller so you guys can see this without it wrapping so much. Do you wonder if we can get it so it's like almost? I feel like also I should probably call this. Oops. Should just call this labels, I feel like. Doing all right, lacking motivation to work today. That can happen. Still got to do it. Start, stop, predicate. Do 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 do. Yeah, I feel like this part is pretty funny. Oh. Because we can make all of this in OCaml. Like, this actually works, which is this is like the funny part, right? Is that this actually runs. Oh, nice. Nice, Aid. Very cool. Like, if we go to this. See, normally it would have looped to 10. You would think it'd keep looping to 10. But magically, return works, which is pretty funny. Go to func. I just don't know how much of this I can explain in one video. I've been trying to figure out how can I explain this. Because the main concept is not crazy complicated. There. Can draw out something. See if it makes sense, chat. Where'd I put my pen though? Yeah. You guys see this? Oh, it's a different one now. That's not the right IP anymore. One sec. Maybe I need to go back to. Oh, maybe I put this. Did I put them? Oh, I was in a different one. Nice. There we go. Okay. So I still don't know how to explain this in a video, right? But basically, it's going to be something like this, right? Because the question is, wow, that looks so bad here. Let me actually write properly on the table so it's legible. Okay. What is GOTO? Right? Because this is kind of like, oh, I should say, what did we do today? I didn't update this. One sec. Working on a script. All right, there you go. So, oh, that's me. That's me. So this is kind of like where I want to start the video. Number one, what is GOTO? But then I want to show what we're doing in OCaml, because the like goofiness of the scenario is basically this. We have a function call. Inside of call, we basically do try like function, okay? And then with, then we have like, did it return something? Returned. Then we'll return it. Then our other option is we catch an exception. And if it's GOTO with a label, then we call function again with the label. This is like the trick of this, which basically makes it so that, right, if you've got, you know, some function, and you have like label 1, label, maybe we'll just call it like 1, 2, 3. If you're in here and you say go to 3, you can re-enter this function and start here. That's like with a trick that I'm doing, which is but I still don't know how to I'm still not sure how like a good way of explaining this is, because basically OCaml doesn't have, so like OCaml no early return, right? No GOTO built in, because it's a bad language feature. So how do we do this? We raise an exception to leave the control flow, right? But then because we're handling this inside of here, we call ourself again, right? So it's like, I should call this func. That's like the trick, right? But I don't know if this makes sense. Like, I don't know a compelling and easy way to explain this. What's up, Peter? Without taking a long time, basically. That's sort of the thing that I'm not sure what to do. You will need a loop. No, you don't. That's what I'm saying. Oh, so I already implemented this. So basically what happens is like, here, we can draw an example, okay? Let function, we'll call it let foo, right? equals, and then it has basically like this. Oops. This is the simplest one. We make a function called GOTO, but what does GOTO really do? GOTO just raises an exception, which sends us out of the function, right? So it's like, normally if you have something like, you know, x equals 1, x equals 2, let's say like throw, oh no, x equals 3, return x, right? Like in JavaScript land or something. I'm gonna go to an okay. Well, yeah, I already have it implemented. I'm trying to figure out how to make a YouTube video about it. Right? Like everybody knows this doesn't return a function, or this. Anything other than Windows Terminal? Yeah, I think GoC would be better than Windows Terminal. I think GoC is great so far. So what happens in this function, right? Instead of, it doesn't return, instead it raises. Right? We're following here. Maybe this is like a better example to start. Am I trying to? No. This is for memes. Right? So like this part, lol at the stream title. Thanks. I'm gonna, that's the video or title of a video I've been cooking on for a while, but I just really need to try and make it. So, but I'm still not sure what the compelling way to explain. But basically, I've been writing up, because like showing some history of GoTo, I feel like would be fun. Some simple examples from C, right? And then be like, oh, I kind of feel like here, I don't know where I want to put it. You should probably jump again after catching the exception. If you call the function again and the exception handler, how will it be able to raise GoTo again? Because it's going to call itself from the same thing. So like what happens is this call function here actually looks, well, here, I've got it right here. What does it do? It is a recursive handle function. So it calls the like implementation basically, and then it calls itself back again. Yes, exactly. The catch is the same function. Yeah, maybe I should have made. So the function itself is an argument that you pass, right? And then you basically call itself again. So you pass in an implementation function here, which we could write this slightly differently. I don't know. I'm still struggling to figure out how I can write this so people can read it. or I can skip some of this code and I can show it after doing the explanation. That's what I don't really. I'm struggling to figure out what the right way to do is. Hey, little boy, which theme? What are you talking about? Recursion? It is basically recursion. So I stole this part of the idea from a Sozin video where he also does something very similar. But then we did something even more cursed. I don't even know. We did something even more cursed, which is what I want to end the video with because I think it's quite fun. So here, I'll give you the... Let me make a new page and we can chat about this part. So it's like, okay. So in V1, right? You have this idea of exceptions as control flow. That's basically the trick, right? And we use effectively recursive function to call itself, and we use variants, or you can think of enums as labels, right? So that's like the V1. The V2 part is we use effects as control flow. You're saying I use Berkeley Mono, although this is my handwriting in case you're wondering, in case you couldn't tell that it wasn't types. People say, "Wow, TJ, you look like it could be from a computer. The way you write, it's so easy to read and helpful." We definitely know what you're saying without you having to say it out loud. But so the V2 part, or the extra goofy version, is effects are like resumable exceptions. So what does that mean? Maybe we need to get a better example for this one too, because the one that I have, I think, is maybe too complicated. But this one lets you come back, which is kind of crazy because it lets you resume after you've done some other work, even if the other thing could have returned earlier. So you could like return from the function, but then still have to go back and do the original thing. Questionable. Very cursed. Right? Because basically, how could I draw this? What would this even look like? Right? So it's like, if you imagine you have a function like this, and it looks like this going down, right? Some function. Okay, a GOTO is like jumping from here and going to there, or jumping from here and going to there. Right? These are like GOTOs. This might actually be... Actually, this might be a nice way of picturing this. But here's another scenario. You have a function with some way to read it top down. And you go to here, and now you have some parallel track. You get to the end, and what does it do? It just says, oh, okay, I'll go back to where I started, and then continue down. Which is kind of crazy. You understand? If you don't understand. Yeah, oh, definitely. I mean, lots of people know what GOTO is, but I'm trying to show what the goofiness of this scenario is, which is like, this is effects, which is a resumable exception. Right, so that's the goofy thing, is basically like it saves off. This is probably not the right picture. Maybe something more like we start here at A, and then we do like a comeback to B. So we go over to here and we go down and we go to B. What happens is we basically save this off into another spot. We can continue, and then we go and start executing down from here. Yes, continuation is a better way to, but like in the way that we're like talking about it in the video, I feel like talking about it as a resumable exception makes it clear what's goofy about it, right? You know what I'm saying? They are called continuations, yes. Yes, go defer, kind of. You can actually implement defer with this strategy. Sure, it's the tablet you're handling. So that's actually like what I did was defer basically says, hey, in this case, what did I want to do with defer? Defer goes and it puts some things in a list of functions to execute later. And then it continues going on, and then once we get to cleanup, it runs over all the deferred functions. So let me see exact. What do I call this one? What do I max defers? Right. So there. So this just shows how scuffed this control flow can be. Because in this case, we tried to put two defers into... We tried to defer twice. Oh, what up? What up? In this case, we tried to defer twice, and we said that's too many. So instead of going here, we just said go to cleanup, and then it does cleanup, and then it's done. Okay, right. So that is what I did, which makes sense. If I change this back to 5, then this will do both of the defers here, and then that's great. Clean up, deferred, deferred, and done with reading. Yeah. Does your C course cover mmap and unmap? No, it does not. Not in any like meaningful way, Ferret. Because, yeah. No, it doesn't. So I wonder if I should just pick this as a particular example. The problem is, like, this control flow is so goofy. I don't even know if it makes sense for a YouTube video. Like, I don't want to accidentally make a 45-minute lecture. You know what I'm saying? Like, it won't be fun. Yeah, it's not that part of C. It's not really interested in that variant. Why not use iteration? Well, how could you do this with iteration? The examples I'm giving, so first off, none of these ideas are good. They're just showing that we can do it. I just want to show I can make GOTO and I can make early return. That's all. There's no other goal, really. Yes, so we are doing effects. So part 1, you don't need effects. For just regular GOTO, you just need exceptions. For the goofy one, like this defer here, which says run this once we're done, you really don't, you could do this without having to do this idea. This is like, I'm not sure if this is even a good example, or because there's other ways you could do this. There's nothing really. Oh no, the interesting part is this. This is why you would need it to be like, this is like a automatic error handling thing, which is funny. Okay, so yeah, let's take this as an example here. In this case, what we have is we have some function, and what are we going to call it? We'll use the same name, so that's easy. Oh yeah, it's basically just like, it's just read. It's more or less just read, right? And we do some like setup, and then we read, and then we're reading, and then we have some way to handle defers, and then we have cleanup. Right? That's basically what we have here. Okay. The normal thing that I'll write this in a little bit better. I'll try and write more carefully. So normally what happens is you just basically execute, you know, when we get to read, we do something like we say, hey, I want to handle these defers. It goes into here, adds it to a list, and then comes back to where it was and resumes. Right? Maybe it should be more like go into here and then it comes back to here. That's normal OCaml control flow, right? Like basically call the function, came back. The problem is, he said, what if we want to handle where we could only do 1 or 2 defers for some reason? This is a kind of dumb example though, so I don't know. Maybe that's dumb. What do we do then? Well, then we say, oh, this thing can actually decide to just go straight to here and then never resume. I don't know. Yeah, I mean, they're continuations, so it's not like it's a common like idea. It's just kind of funny doing it here where you can like normally the defer, it's actually going to do a GOTO. It actually it calls this. It puts this in here, and then it comes back to where it was, which is interesting. So it continues down, but it could optionally decide not to resume, and then it just goes to here. Maybe there should be like GOTO error or something like that. Never defer anything. Smart. But I just don't know. This probably just is not that compelling of an example. I think it's just too complicated. Like, do we have a better example of where we could use this idea of resuming it or sometimes going to a different spot? I don't know. I think the main problem that I've been having with the video is the examples are just like unhelpful. They're like funny once you get them, I guess, but they're not really helpful. That's kind of thing that I've been... How is it resuming? Is it pulling? No. It uses exceptions to change the control flow. So the defer happens after, like when this function is getting finished, right? It's like it happens in cleanup. Retry classic use for GOTO. You could simulate network failure or something. Yeah, okay, so... But in that case, what would be... So the scenario is like from C where you would do this, right? This is the example from Sozin. Great video. Where it's just looping. This one is easy to think about, and I wrote this one already. That's fine. Those ones are those are fine. I'm trying to think, is there an example like in C breaking out of nested loops? Yeah, that's not too interesting. Handling errors, GOTO error. Simplifying cleanup. Because that's kind of what we have here. The resumable part is the thing that's not interesting. Yeah, Sozin's great. So I feel really confident in explaining the first part here, where we have like a loop. The thing that's like different compared to Sozin's, the one thing that I think is like cool about the way that I have this is like here you name them with strings and then you write an individual function for each one, which is like, it's cool. But what I think is like fun this way is we actually use like a type. And so you get like named variants. I could make this shorter by doing like a derive and some other stuff, but I felt like it made the video too confusing. So I'm not really sure on that, in that regard. But this is basically like loop. If index greater than or equal stop, then go to done. Do this, increment the index, go to loop. Which maybe we should just write this as like... Maybe that's simpler. Maybe that's simpler for people. All the interesting go-tos here are difficult to implement like this. Jumping into a case statement or inside an if block, you're limited to labels that function scope. It can already be... Those can all be obviously done with normal control flow. They can all be obviously done with normal control flow. Is that true? No, they can't all be done with normal control flow, I feel like. Well, they could be, but they're a little bit more annoying. Like the one that I think is more interesting is this one where we have an early return. This one is much more difficult. This one is much more difficult to write in OCaml because we don't have early return. Right? So like when you're looking at this, this is like, this part's actually quite interesting, right? Like the early return is a bit more complicated to write in this same style. Because I think this part's pretty cool, because this literally stops executing the rest of this function. Right? So it gets early return, it does this, and then it stops. Whereas if we said equals 35, right, or something like this, that condition will never happen, and it will keep running and then be done and say, I have failed, right? Right? If we switch to 8, it's only going to go to here, etc. Make a macro drive, make simple at GOTO label. Make GOTOs be a simple at GOTO label. But that doesn't really work either. What would we do? And it inserts the code. I'm not sure what you're saying. What would it insert? Right now, this is done with just regular functions. This is Neovim. I also don't want to write. I don't want to spend 40 more hours writing a macro extension just for just for a thing that I think is bad anyways. We're trying to figure out how to explain this video mostly. Oh, I can probably put, that reminds me. Did I publish the GOTO considered hilarious? Okay, nice. All right, there you go. So now this has got where I'm at here for some of what I'm writing. Because this one I think is this part is fun. Maybe some use cases will be solved by coroutines, like the classic reformat of HR and one cherry jumping between two loops. Oh, that could be. Yeah, maybe we could just look at what a good example of actually using coroutines would be. That's funny. Yeah, that could work. Because those are actually real examples that may provide some compelling use cases. Sure. Yeah. Let's We'll ask ChatGPT for some classic examples of coroutines that are simple. What are some classic examples of coroutines that are simple to explain? Make them more like ones that are similar to GOTO. Yeah, yield, I guess. The thing is, I don't want it to turn into actually good examples. I don't know. I don't know, chat. The problem is, like, I want to show ones particularly for GOTO. You know what I'm saying? Not necessarily just like what can coroutines be good for, because there's a bunch of really good use cases for effect. That's not really the point of the video. What happened to React? By the way, we're still gonna do it. GOTO Panic, classic. Yeah, I've read the original letter. Yeah, it's GOTO is bad. Yeah, I agree. That's the point. But it's funny. I'm good, quick. What about you? So I feel good. I feel good about these two examples. The resumable one is the one where I'm not sure, I think, right? Like simple loop. Then we introduce like, then we introduce the return. That's good. But GOTO claims the only thing I've ever used GOTO for. Yeah, same. So then I'm thinking, what would be a funny or like an interesting thing to show for I wonder if we can do one instead that's more like, let's just say we yoink this whole thing and we go counting. Yeah, let's go somewhere here. We'll put this inside here. This inside here. All right, so let's go to here and see if we can think of because the interesting part for this is I don't want to do deferred. It's too confusing. I don't want to do lines. I don't want like almost any of the stuff that's in here probably. So like we could have like a init. We can have what's Tijni color buddy? And then let's do something like, let's just say something like increment of int. And then let's just go to like done. Something like this. All right, so let's go here and we say init. And we can do something like let's we'll say like count is ref 0, something like this. Let's do and then this would be something like anchor 2. And then let's just delete all of this for now. Oops. Go to done. We'll do all of this. We say done. And then let's do count. Something like this. I don't know if this will work. Oops. Anchor count. N. Oops. Why do I keep writing that? Open, make, go to here. Val not labeled. Chunk, label, value, label, value. What do we need to return? Yeah, what did I do in the last one? Let chunk is all of this. Module T, make, go to. Oh, right, okay. This should be init. Values do not match. Chunk, label, int, value, value. Oh, right. What did I say value would be? Right. We say value. We can say int here. Nice. Done with counting. Count. Okay, cool. So this part's not that exciting yet. Implementing finding station could be the use case, though the switcher, the match, and Rust would be a lot cleaner. Yeah. I mean, there's better ways to do basically all of this, right? Thinking about building my first NeoVim plugin for running stuff. How would you implement something like IntelliJ or VS Run button in NeoVim? You Vim system, I guess, and run it. I don't know. Why you're trying to make my mind kind of feel hurts. Yeah, that's okay. So in this case, what's the goofiness of this? We can do something like
made it properly tail recursive. Like,
yes.
Ocaml is actually my
I
favorite.
basically want to resume this again in sort of a goofy way, which would be like, yo, B Dev, hey, thanks. 4 months. Thank you. Thanks for the subscription. Appreciate it. Count is count plus n. Because what I want to show is we get to here, and then I want to do something like if count, greater than 10, then count. Or let's do like match count with x when x greater than 10, and then we return x like this, right? Otherwise, we'll say still counting. This won't really make sense, right? So it's like still counting. What do I want to do here? I want to go do something like what happens if I say go to or come back anchor 1? I actually don't know what it's I have to think about this for a little bit. What would it do here? Came back. So we never get to here. We go to here. We go increment 2. Okay. We go to done. What's up, Anash? Welcome, person that I don't know how to say their name, but thank you for being here in YouTube chat. So we go to come back here. Anchor X. So it's going to do this. It's going to get done. It's going to go down to here. Oh, because we get to down to here and we return a result, but we don't actually want to do that yet. Exactly, Zachin. Thank you. That's exactly what I'm going for in the video. Because we return here. I thought that then this we'd get here and then we'd do continue K and we would come back to here. Are we getting this at all? Sending. Yeah, so we do get this. We go to the come back. I thought that I would have kept on iterating on this. Let me think about how this works. Oh, let's try this actually. This might be interesting. Is this going to be 2? No, because it'd only be 11. Does this return anything? Oh, let Y. How do I know what type this is? Because my... We say come back, label, value, come back, label, come back always has unit. Okay, that makes sense. Yeah, yeah. That's good. That's what we want. So I'm just trying to think. What I thought was going to happen is we would run that chunk here. Go to increment 2. Yep, that makes sense. And then we do go to done. Oh, we're getting to here, and then we're not going to resume afterwards because we scuffed it with GOTO. Oh, actually, that makes sense. Because GOTO breaks the control flow. GOTO breaks the control flow. That's actually what I wanted to have happen. Right. Because this one's calling GOTO done. Of course, chat. Of course. Of course. Of course. What kind of Stevies are... All of them. All of them. He's waiting to come back more. I know this comes from intercal or accessory language. What does it do here? Well, the thing that I wanted to show is that it like does a bunch of random stuff, could even get to the end of a function, and then it still resumes itself. But the GOTO is going to scuff it, which makes sense, right? Because we're going to say like, hey, we had GOTO here. What? Oh, I think my in-laws are over here. Doggo is, one sec. Yeah. Okay. Is revealing dynamic IP an issue? I don't know. It depends. What do you mean? Hey, Sweep. Good to see you, buddy. Yeah, so I forgot that at least the way we're handling this right now is that if we do a GOTO here, we're going to break all of our comebacks. Right. Right. Is that what we want? Should I try and think about this in a different way? Because we never end up resuming what we had here. Yeah. So maybe that doesn't work. That doesn't work that well. Because what I wanted to show here is... What did I want to show? I wanted to show that you would eventually come back to where you were and resume. It's a little bit hard to. So it's like GoSub from QBasic. I don't know. I've never written QBasic. Right, because kind of like what I wanted to do would be... Is this drawing? What? Hello? It's just working. There we go. Okay. I wanted it to be something like, you know, you're thinking of a init, and then you have increment. These are not written well enough for you to be able to read. Init, increment, and done. And I wanted to do where done would send you back to here. And then you might have like, you might kind of loop this a bunch of times. But then eventually you would get back to the first one that you sent and it would come back. It's kind of like resume. But I don't have that working right now, at least the way we have it here, because we're discarding the continuation that we're supposed to use when we have effect. Which makes sense. It makes sense. Oh, I wonder if I write this one with exceptions, but this one with effects, maybe it will work. Ooh, chat. Because what did I do before? We can go like this. It's not handle anymore. Go to label here, exception go perform. No. So this is raise. What did I have before for go to func here? So these are exception, go to, raise, yeah, perform, yeah, because go to is right, chat, right. So then what did I do here? I just said handle, where is this? So it says, oh, but I think I wrote that wrong. I think it just go type exception, yeah. Bro, who in this earth do oh camel? Me. At least one person. No, Keo, you're good. You're good.
Yeah, but let Dan Vale say weird things.
Handle label, expression of type unit value. Go to label, go to label. Yeah.
If you want entertainment, go and watch clowns.
Got 'em. Impl, go to label, L next label, handle here. Go to label, handle. What did I say something different for handle here? Oh, do I have to pass F again for this? Because this is F, unit to value. Oh, this is tricky. This is tricky, chat. OCaml is the best language. Okay, so I should be able to do this still, but this is just not quite right. As expected type unit to value. But doing this, because what do I actually do for this? We say start is handle, fun, go to label. Oh, right. I just say this. Okay. So let's see where we're at here. Dune exec this with nothing. I'm thinking we are getting an infinite loop here, which is interesting. That's interesting. Or something's going on. Why are we not printing anything at all? That's an interesting question. I don't know. Steve Richards was the second streamer or discussion warranty over presence. Oh no, you're totally right. Oh no, you're totally right. No, I think I did yesterday. No, I think you're right. I think I didn't do it yesterday. Keck W, Dan was right. Keck W, I didn't tell you I was live. We are doing GOTO considered hilarious. Trying to find a way to turn this into a video. Good point, Dan. Good point. Yes. Once again, Dan saves the day. Okay. Wait, how are we not printing anything here? Okay, so what happens? We call F. Handle. Go to label. Wait, no, this just calls itself. I'm stupid. I'm so stupid. I'm so stupid. That doesn't do anything at all. This just literally calls itself over and over. Do it. What up, Nix? Go to pantry, move, snack, go to sleep. Nice. My dog's name is Ember. Named after Ember JS, of course. Obviously. Because this doesn't make sense, because we're going to call this, and we're just going to go to this label. Wait, what? Handle. jQuery, Tailwind, CSS. It's just a fact of life, chat. It's just a fact of life. Go to, comeback label, chunk. Oh, chunk. That's what I want to call. I want to call g.chunk go to camel label. This. Make go to fatal error exception. True. Oh, handle fun this. Like this, I think, right? Okay, nice. But does this kill our exceptions? Does this throw off everything here? There's no way, right? Let continuations is ref this. Right? So if we go continuations this, will this still compile? That's why f value, but expression type a, f is ambiguous and would escape the scope of its equation. That's a shame. That makes sense. That's good that you can't do this because this seems like a really bad plan. That seems like it does seem like a very bad plan. I do agree with that. It doesn't seem like a good idea to be able to capture these outside of the effect. Okay, I can buy that. Could escape the scope of region. Definition of type continuation 2. Yeah. Why is anything else? Emacs is pretty cool. So that is a good idea that we can't do that. Okay, sure. I used to do when 1 equals 1. That's funny, Ferret. So I guess that makes sense because this still breaks control flow and it breaks control flow inside of here. Oh, maybe we need to do something different here, though. Maybe we need to do something different back here. Maybe what if we make this even more powerful than before? Can we make this even more powerfuler? Because basically what we need to do is we need to make sure that no matter what happens here, we do this. Which is almost like try this with, or we could do, no, we want to go match this with results. I don't know if that works. We can say with exception, doesn't matter. We're gonna still continue K. And we'll allow the effect to bubble up. Oh, I wonder if we need to special case doing this. What if we write special case, go to label, and what are we going to do? We can go handle. There's no way that this is a good idea, right? There's no way that this is a good idea. No. Oh, no. How do we get this printed twice? Okay, so now we've done something very cursed. Now we've done something very cursed. Because we didn't do it infinitely. That's part of the problem. We're only doing one level here. But the like goofy scenario of what's happening here is, look, so we're adding 1 to all of these. And then we get all the way down to done with count here. So we get done with count 11 and we return this value. But we said come back. So we returned here, but now we're going to resume here. The first one that we sent is a 2. So now we get done with count 2 instead of done with count 11. So this says, this is like done current value. Right? Done current value. We think it's 11, but just kidding. Came back. We go outside all this. Oh, no. It's good. We come back all the stacks here until we get to the first one. Oh, okay. So this is properly cursed. This one's properly cursed. Yes. I think this is the way. Here. Oh my goodness. Oh, that's okay. So that's pretty good here, chat. That's pretty good. Let's walk through our control flow here. Okay. One, a knit. We're going to start with counting. Let's just move it by 5. Okay. So we'll get a few less prints. So it was 0. Now we're doing 5. I'm going to get rid of sending. Maybe you could only remember that you handled the comeback and executed only once. No, I like that it's this way. Because this way is pretty hilarious. Right? So it's like, okay. So we get our first one. We go to increment. Say, oh, by 1. Okay, so now it says go to done. We get to here. It says, oh, come back again later. Okay. So it says, sure will do. I go to here. I add 1. Go to done. Okay, sure. Add 1. Sure. Go 1. Sure. Go 1. Maybe this is actually easier when we do X less than this. Let's yoink this here. And then let's put this here. Because I think it looks a little bit. I think that looks funnier. Or this is maybe better. So it goes into here. It says come back. Eventually it gets past 10, right? So it says done. Current value 10. So it says what we came back with. I wonder if versus. And we just put X here like this, right? So it's. Yep, chat, we did it. Okay, is everyone seeing this? Is everyone seeing what's happening here? Right? Okay, that's properly cursed. That is exactly properly cursed, right? Because now we're gonna resume back. That's just normal call stack. Except it's not, because we're raising exceptions and other things in the middle. This doesn't have a, you know what I'm saying? Like, because it does GOTOs in the middle. So we're doing GOTOs. We're like doing a GOTO here, right? And then, because normally after you do your GOTO, you're done. You know what I'm saying, Keo? Oh, don't get me wrong. Yes, but it's acting like a normal call stack. Agreed. Except that the state is like changed, right? So it's it's just not. Yeah, that's something. All right. That sure is something. Wow. Try just writing more project for me instead of doing what you want to do. I'll think about that, Nix. I'll think about it. It's an interesting proposition. Current value is 10, and then it came back, done with count. The other goofy thing is, okay, so here's another thought. Okay, chat? Here's another thought. Because we can make this conditional. For example, look at this. I think I can do this. Label and condition. $31. Go to. Oh, we didn't say what chunk this needs to be. Is this not how I write this? Oh, I can just say this. Okay, yeah. Closed unit F full an expression type label. 34. Come back. Oh, come back is the one that needs to label this. Oh, we can change it to this. There we go. That's better. Can't I do this? Already subscribed, dude. What up? Perform, label, condition. Oh. Come back, label, and condition. Oh, right, because now this is a function with 2 arguments. Can I do this? Oh, this has to be one. Oh, right. I think. Okay, so let me just go back a sec. Let me go back. Let me think about how I can write this instead. Okay, because I'm thinking what would be even more cursed. What would be even more cursed? We could do something like this, where you pass some function and you just say false. Like this, right? And then this condition could decide, or maybe just a Boolean. Maybe it's actually easier if we just say, well, I don't know. I'm just thinking like, what can we make it more cursed? It's probably too confusing, because we could optionally come back depending on the state when we arrive home. But just like, no, I don't think I need to do this. Forget about continuing. Just let me go where I was going to go before. What is your relationship between the Primogen? A relationship? I would say best friends forever. I don't know. Platonic, obviously. What else are you wondering? YouTube chat asks the weirdest questions. Where is my X chat today? Hello, X chat? Say something. Okay, so maybe that's not a good option. Ooh, you could make it. What's up, Space Nerd? I wonder if we could make it so that come back could return a Boolean. We could decide if what we want to do. How long have I been programming? Like 10 years or so. He's been working for 1 hour, 10 minutes. True. Today, yeah. Actually, I was doing some before off stream. That's the canon as per the anime. Dude, you're not even close to caught up on the manga. Okay, this one actually works pretty well. This one actually works pretty well. So I don't know if there's another version. I feel like I should still show the deferred one, because I do think that it's still interesting to show that we can run these functions. But I mean, this one is not that interesting in a way, because it's just, unless I like built defer into here. Like maybe I should have done that. But still not that cool. Ronick, welcome. Okay. think this one does show that we're like modifying the same state, but we keep the original stacks, which is pretty funny, I feel like. After showing how we can do this with exceptions. I wonder what would happen if we added return as well. Like, what would you, if you were going to do this and you had return, right? Would you expect comeback to happen after return, or would that override comeback? Like, that would be the very, like, Like, let's say you added early return to this scenario, right, chat? And you're going down, you say, oh, you know, it's greater than 5, you hit return. Do you still come back, or do you not come back? I feel like it's more scuffed if you come back, but is it like... No, it's actually more scuffed if you do the reverse, where return says, I'm going to beat everything. That would be pretty... That's... Yeah, let's see what this would look like, and then Geez, so now we know wherever we had chunk, we need to say go to return, go to, whoops. How did we do this before? What did we say for return here? We just lied, right? Oh, we said returns unit. Oh, that's funny. I guess that makes sense. I guess it makes sense. We're just going to lie completely to the type system. Yep, that makes sense. That makes sense. Okay, so wherever we have chunk, we should say go to, return, come back, and label. And then this should be chunk, 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 chunk. And then this should be value as type value A, but expression type label units. Oh, wait, it needs to be value? Oh, right, that makes sense. Yeah, this needs to be value unit. Okay, nice. 27. Counting. Oh, 61. 61. What happens if we say return X here? Yeah, okay, cool. Nice. It returns return 9. Yeah, okay. Yeah. If X equals 7, then return X. X. Oh, no way, dude. Okay, so now we have this. Come back. Done with count. Done with count. 5. So I think I want return to kick us out no matter what, right? Oh, so this should probably then be an effect. Return. Value. F. Something like this. Perform. Label. Oops. Everyone's result on this side of the pattern. 30. Oops. 37. Oh, whoops. Yeah, there we go. That makes sense. This should now be effect, return, value. Oh, wait. If x equals 7, then return x. I would have thought that we'd be done here. That's what I'm trying to see if we can get to work, right? I don't want to continue anymore. I don't want to continue anymore! I'm locked in. What's up, Gorge? Teacher contributed one of the most used programs. Also teach for kids. I messaged now though, Joshua. I mean, Dan did have to remind me, but I messaged before. All right, so I'm just thinking. Whoops. So do we even get to this? Let's just go. Oops. Okay, so we are getting this. It's just that return doesn't do what I was hoping it would do. So I was thinking, okay, so we handle this. We run G chunk with this return. We get effect return. Just I type this. Oh, right, because that's expected to return nothing. Okay, okay. This just turns out GOTO isn't funny anymore. Oh, it's still funny, boys. Don't worry. Because we need to basically raise an exception out of this. Raise returned value, something like this, which we don't have yet. So let's just try this. Returned of a value. Early return. Nice. That's the only place where we do this, though. Returned. And we can say value. Oops. Value. There's no way that this works, right? Yeah, I didn't think so. I didn't think it was going to actually stop. The problem is we get to here. We raise this exception here. We don't do this. Otherwise... Are we even doing this? So we do get to this return. We should. I thought then we would raise here. This would get passed all the way back out. Oh. Maybe we need to make a whole separate function. Oh, that would be so funny. Can you teach me auto commands? I have some videos about it, I think. Does anyone go ask for programming oriented dactyl 5x3 with Homo mods? Yeah, I don't know. I don't do Homero, but yeah. Oh, but you have a small one. Yeah, that makes sense. Yeah, that seems tough. Chat. Maybe it should be that this one goes whenever we see Um, no, I don't think I can. I'm not sure that I'm going to be able to get that to work. Not without doing a lot more difficult stuff. Oh, I gotcha, Alexi. Yeah, I don't have any good info. Maybe someone in chat knows though. Dang, I thought maybe we had an extra goofy version as well here, but we are getting to here. We raise the return value. I thought that would keep on. What happens if we comment this out? We fail this entire thing, right? So start. We do try. Or we do this. Match this with value, exception, value. Oh, oh, chat. I think I actually don't even need to do this. Ah, yes, Chad. Yes. Now the question is, do I even need this at all here? Because this will raise an exception. This will bubble up to here, which will bubble up to here, which then won't do anything. I think I don't even need this. And we can just do raise, early return, this. And then we don't need this one at all. Got it. So then this actually can just be return. Same thing. An early return can just be this. You love to work with okay. Yeah, I think it's really fun. Okay, now we're talking, chat. Now we're talking. Because now early return beats come back, but loses to GOTO. Or comeback loses to return, but beats GOTO. Yeah, I think we've got something going on here, chat. I think we got something going on. Because if we comment this out... We comment this out, then we'll continue to do the comebacks. We uncomment this, and then we're going to actually skip doing the rest of the comebacks because we're doing that. I think that works, chat. I think we got something going on. I was thinking my comeback's too late. R.I.P. Like, this looks like it's the end of the function. It looks like it's done, but it's not. Okay, nice. Chad, I think we really got something here as a good example.
Up on a flying monkey
What up, JD? Because I
Matt and his
I
family
think
are
with this example, right? We can actually we'd show first this. Okay, what do you think is going to happen? Go to increment by 5. Sure, we'll increment by 5. Then we go to increments. We say, okay, sure, what are we going to do here? We're going to increment some number by this. Yep. And then we do that. And then we say, go to done. So we're done. We say, okay, what do we want to do now? Oh, we're just going to come back here after incrementing by 1. Okay, so we go to here and we increment by 1. But then we come back. We go here, and then we're going to keep doing this. And every time, we're adding basically one more increment to our stacks. Just like, this looks like a function call. Except, we can interrupt this by then doing a return. And we can just escape everything here, and then we get, after execution, we get this. Final result is 7, even though count is now, 10. Reinventing loops. Oh, but this one is more than that, right? Because we could do whatever we wanted inside of here. This could be anything you wanted, and then we'd come back, right? So it would be like, let's say you got a resource and you wanted to release it or something. That's why I was thinking of defer in the other one, but I feel like maybe it's just too complicated. I don't know. Is this metal? This is OCaml, yeah. We're just pretending that these are things, yeah. Okay, I think that maybe is a better example. Is there any way to write GOTO in PHP using FFI? I guess you could probably manipulate something about the OCaml state, like, directly. Or about the PHP state directly. I mean, it would be very hazardous, I think, probably. But I'm assuming it would be possible to do. This is actually great because we can go through each of these and we have go to and return. And then we can add come back, basically. Say come back loses to go to. Come back beats go to. Yo, Calder.
Like,
one whole
OCaml's
year.
actually my favorite.
Dang. Thanks, buddy. It's pretty funny. That is definitely the most cursed one. The question would be, how can I explain this? Oh my goodness. How can I explain this? Unexplainable, dude. That's what I'm saying. That's what I'm saying. Like, it's actually kind of hard. Hmm. I do kind of like this. Yeah, this is literally just a ligature. Yeah. Yeah, I don't know, Chad. I think this is good. Get to the end, we can return the result. Final result 7. Return 35. Just completely random. Yep. Okay, so that's all working. Maybe this is easier to see if we just go. What if we rewrite this section as let count is, or let current count in if current less than 10, then we're gonna do this, and then current else current. Right? That's the same thing. Well, we can take this here. Fake return. Because this is basically the fake return here, right? It's like, okay, it looks like we're all done. Right, Chad? It looks like we got to here and we're gonna finish. But it's not. That's just fake news. Proves it's depressing instead. No. So far, we've definitely got funny things from it, I think. I think we're good. Trying to figure out what's the easiest way to write this so people can see it, though. I do think this one is pretty... Oh, wait. Actually, let's go here because I still want this. We still want to have this here. Because I wanted to write it as imperative as possible, right? Maybe we don't even, I wonder if we just don't even use this. It's a little, I mean, I like showing that we're changing the same state. That part is pretty fun. Five, 6, 7, 8, 9. Maybe we should just go count current like this. It's probably a little easier to understand. We just go here, we go current. Oh yeah, because the other goofy thing about this, right, is this function we didn't even label as recursive. I didn't even realize that. Oh, that's even funnier, dude. I didn't even realize. Like, we don't even call this recursive. Like, so it doesn't even look like this is possible. I didn't even think about that as a... Even though, like... What up, Nature Dory? Oops. Okay, let me go grab a drink of water and maybe some lunch. I'll be right back, chat. Cool, we're back. Okay, I actually gotta go though, because we've got my kiddo's birthday party later today. Wow. Hey, fancy meeting you here at the end of the video. Just go ahead, give it a smash. You know, wow, the like button. You can make fun of me in the comments for that one. I don't even care because you made it to the end of this video. Thanks everybody. See ya.